Okay, in this section we're going to talk about type 1 errors, type 2 errors, and power. So far we've been doing significance tests in Chapter 9, and we basically never have stopped yet and asked ourselves, what if we're wrong? That is, after we conduct a solid test to make a valid decision based on the sample, what if we find out that the decision we made was actually wrong? As statisticians, we can calculate the chances of an error occurring. There are two ways to make a wrong decision. First one is that you reject your null. You reject your null because you get a p-value that's lower than 0.05. So you've gotten the statistic that was extreme. But later on, they come back and they tell you, hey, that null was actually true, and you said it wasn't. So that's your type 1 error. So you make a wrong decision by rejecting your null, which is supposed to be true. Type 2 error is when you fail to reject the null because your statistic doesn't give you something that's that extreme. So you failed to reject it, but it was actually wrong. Now, all you really need to know for these is which one is which. Type 1 error, first of all, the first reason why you do a significance test is because you want to be able to reject the claim that the population is putting out there, the parameter. And that's your first thing that you want to do. And the type 1 error is that you're wrong when you make that decision. Type 2 error is the opposite of it. Probability of making a type 1 error. Type 1 error occurs if we reject the null when it's actually in fact true. We choose to reject the null when we obtain a p-value that's smaller than 0.05. So the probability of a type 1 error is equal to your significance level. Remember, that significance level can change. Either you can change it, usually that occurs out in the real world all the time, or for our purposes, the problem that you're doing might actually change your alpha level. And remember, that's just what you compare your p-value to. Well, here's a little diagram for probability of a type 1 error, and in this case, your alpha is 0.10. So if you're comparing your alpha to 0.10, or your p-value, excuse me, to 0.10, that means if p is lower than, if your p-value is lower than alpha equal to 0.10, then you reject your null. So the probability of making a type 1 error, rejecting the null and being wrong about it, is equal to 0.10. Basically, the probability of any type 1 error is equal to your significance level, whatever it is. To decrease the chances of a type 1 error from occurring, just decrease your alpha level. That's the way statisticians get through and are successful, because they manipulate the situation to work for them. And they just change what their alpha level is being compared to. Probability of making a type 2 error. Type 2 error equals the probability of failing to reject the null hypothesis when it's actually false. So type 2 error occurs if we fail to reject the null because we have a statistic that gives us a p-value that's larger than alpha equal to 0.05. But we later find out that the null was actually wrong. However, the probability that the statistic falls outside the rejection region is not the area of the unshaded region. Okay, this gets a little complex, so I'm hoping to have it make more sense by the diagram on this next page. So you have here the sampling distribution of p hat if your null is that p equals 0.08 is true. So this is in your middle of your curve right here. This is your 0.08, that's your null. Your HO is that p equals 0.08. That's what you're told as a given fact. And for this situation, it's not on this paper, but your N was actually 500. So in this situation, the p hat that they get is 0.0 0.0999 based on their sample. Well, let's take a look at that. If I go to my one prop z-test in my calculator, stat test one prop z-test number 5, and I put in 0.08, and they had 0.0999 for their times their sample size of 500, gives me 49.95. I can't leave that. The calculator will get mad. They want whole values. I'm going to round it up to 50. And they're trying to see if the sample statistic is larger than 0.05 or 0.08. So calculate, and we see that we get a p-value of 0.0496. So if we round to 4 decimals, then yeah, that's lower than 0.05 by just a tiny bit. Of course, this p-hat was rounded up to 0.1, which is further from 0.08 than 0.099. So whether or not they would reject, it's right on the fence pretty much as to what to do with that one. However, they show us here they're trying to make it right at that 5% line of 0.0999. That's the p-hat. But then it comes back and says, what if p equals 0.11? In other words, the null that p equaled 0.08 was wrong. And they tell you, oh, whoops, we made a typo error. The true null is supposed to be p equal to 0.11. So if we look back at our situation, and this page says the green line, I don't have a green line, but if we look down at the situation, here's where the line started up above, where the rejection region is for type 1 error, and whether or not to reject or fail to reject your null. And you continue that same line down right here. This is the cutoff that we were using previously. That same line is supposed to go all the way down. Well, if we plug into our calculator for the one prop z-test and change the null to 0.11, leave everything else the same, and calculate, now our p-value is 0.7626. So it went up, or 0.763. So that's what they're showing. There's a typo on your paper, by the way. Apologize for that. The power of the test is to detect that p is actually equal to 0.11. Now, this area, shaded area, is called the power of the test. And over here, this is the probability of making a type 2 error, which is 1 minus this shaded part, 0.763, and gives us 0.237. Now I know this is all really complex and a lot going on here and trying to explain it to you within just a couple minutes. However, the nice thing about this, I wanted to show you to see visually what's occurring when you fail to reject your null and the probability of making that type 2 error. However, you will not have to actually calculate a type 2 error, or the power for that matter. The only thing you really have to know is the probability of a type 1 error, which is the same as your alpha level. So we're going to flip. What we will need to know is to determine in a given situation which one is worse, type 1 or type 2 error, and that depends on the situation at hand. Are we talking about the proportion of green Skittles that we have in our bag? Or are we talking about sending somebody to jail? I mean, it really depends on the situation that we're speaking of and referring to. Also, as far as relating your type 1 error and your type 2 error, it's like a seesaw effect. You know, where you have your little line here and goes one way, and somebody's sitting up here and they're trying to hang on. Then you got another child and they push off down here and you go up and down. Well, if you try to decrease the type 1 error, then you're automatically increasing your type 2 error. Likewise, if you try to decrease the type 2 error, then you will increase your type 1 error. So again, it depends on which one is more serious, depending on the situation. Power. Power of a test is basically your ability, the measure of your ability, or the probability of, to reject the null when it's actually false. So to reject the null and be right about it, to get a low p-value that's accurate. In a jury trial, power is the ability of the criminal justice system to convict people who are guilty. When the power is high, we can be confident that we've looked hard enough. In other words, looked at all the evidence and gotten a really good sample statistic. To calculate the power, compute 1 minus the probability of type 2 error, 1 minus beta. Again, this part you're not really going to need to know for the AP exam. When we calculate power, we have to imagine that the null is false. The value of the power depends on how far the truth lies from your null. So the further off your statistic is from the parameter, the more power you're going to end up having to reject your null. So the further the sample statistic is away from the parameter, the more power you will have in the test. Because you're more likely to reject the null. To accurately reject the null. Now these other things are questions people might come up with. How do you calculate power? It's 1 minus beta. What's strong enough power? About 80%. And how do you increase the power? From here down, these are the important ones. These ones, not so much. To increase power, to make anything better in the world of statistics, you increase your sample size. Unless your sampling technique was so horrible that increasing your sample size is just going to make things worse. To increase the power from 20 to 80%, that is 4 times the amount, you should multiply the sample size by 16, which is 4 squared. Remember, in all of our formulas, on the very bottom is the square root of n that we're dividing by. Well, we need to undo that square root, so you square things. So to increase power from 20 to 80%, think of like that margin of error. To decrease it, power is the opposite. You want to make it stronger. You're going to multiply your sample size, make it bigger, by 4 squared. Likewise, to increase the power from 30 to 90%, which is 3 times, you should multiply your sample size by 9, or 3 squared. Those you will see in multiple choice type questions. As far as they'll give you a situation, they'll ask you what size sample should you use, and depends on how much power they want to increase things by. And remember, it all boils down to increasing that sample size to make things better. All right, if we look at the back, there is an example that you may see in a free response question or on your next quiz. Clean air standard requires that vehicle exhaust emissions not exceed specified limits for various pollutants. Many states require that cars be tested annually to be sure they meet these standards. Suppose state regulators double-check a random sample of cars that a suspect repair shop has certified as okay. They will revoke the shop's license if they find significant evidence that the shop is certifying vehicles that do not meet standards. So as far as emissions checked, it's something that all cars have to go through. I think it's like every 2 years, and cars that are really old and pollute in the environment really bad and they're cancerous, then they don't get certified and they have to have work done to them. So the question is whether or not the shop is doing what it's supposed to be when it's certifying cars as being okay for the environment. When you look at a problem like this, look down at the rest of the page. What do they really want you to do? Well, I see type 1 error in context, type 2 error, so those are the types of things you need to start thinking about when you look at this problem. Before you can really write the type 1 error or type 2 error in context, it helps to actually write out what the null hypothesis is in context. And basically, the null, the HO, think of the null as always happy-go-lucky place, that everything is good, that nobody's doing anything wrong. So, in the HO, according to the HO, the shop is meeting standards and certifying vehicles that pass the emissions check. The alternative hypothesis would be the opposite of that. The shop is not meeting standards. That's what the state regulators are testing to find out. They're investigating. ... Now, remember, I wrote ... here only because this part's not being scored. This down here is what's being scored. I wrote this part up here to make it easier on me to write these parts. Part A was the type 1 error in context that the state regulators say or determine the shop is not meeting standards. When it actually is. It's actually doing a good job, and the state regulators say that it's not. In this context, what is a type 2 error? Well, the state regulators say the shop is meeting standards when it actually is not. It's passing vehicles that shouldn't be passed. So for each of these, this particular problem doesn't ask for it, but usually they'll also ask for the consequence. What is a possible consequence for type 1 error and a possible consequence for type 2 error? Possible consequence for the type 1 error is that the shop gets shut down. When it's doing a good job, when it shouldn't. And for type 2 error, possible consequences that the shop stays open and it continues to pass cars that are polluting the air. So which type of error would the shop's owner consider more serious? Explain. Well, definitely type 1 error. The owner would have to close his shop, even though he was doing a good job. He'd lose lots of money, his family would have to go on welfare, he'd lose his house, and so on and so on. Which type of error might environmentalists consider more serious? Well, definitely type 2 error. I kind of already explained this one above. The shop would continue to stay open and pass cars that really need extra repair work to them. Basically, they're passing the emissions for cars that are polluting the air. And what is meant by the power of the test the regulators are conducting? The regulators, the power, is the ability of the regulators to revoke a shop's license that is not meeting standards or adhering to the rules.
Teachers and students, please pardon this interruption for one brief afternoon announcement. The after-hours STEM Fitness for Life and
Pause
Walking
doesn't
for
work.
Wellness classes
The
are
announcements
canceled
are
for
going
today.
on.
Again, the after-hours STEM Fitness for
Yay,
Life
STEM
and
gym.
Walking Wellness
No STEM gym
classes
today.
are canceled for today.
Okay.
Thank you.
Will the power be greater if they test 20 or 40 cars? Well, 40, of course. 40, the larger sample size. Allows for a stronger test. And smaller spread in the data. Will the power be greater if they use 5% or 10% level of significance? Well, we're comparing our p-value to the level of significance. So the power is being able to reject your null. So if our alpha level is higher, we're more likely to reject the null. So 10% level, since we would be more likely to reject the null. No, that's not in context, but I didn't leave us enough room to write the context out. H, will the power be greater if the repair shop inspectors are only a little out of compliance or a lot out of compliance? Well, will the power be greater if the repair shop's inspectors? Inspectors? Don't think that's supposed to say inspectors. Will the power be greater if the repair shop are only a little out of compliance or a lot out of compliance, meaning that the shop's really messing up or it's just messing up a tiny, tiny bit and it's hard to find. So the power would be greater if the shop was a lot out of compliance. Because again, you're more likely to reject the null. Okay, so that is for the power, type 1 error, and type 2 error. And I will continue with match pairs on a different recording.